Hello and welcome to the DCD Critical Power Channel. I'm Alex Dickens, Head of Broadcasting at DCD, and I'm delighted to introduce this panel, which will be exploring determining AI's impact on data center power. Joining me, we have three fantastic speakers. Bill Clayman, CEO of Apollo, Calvin Nicholson, Senior Director of Product Management at Legrand, and last but not least, John Consoli, Vice President for Sales, Cabinets and Containment at Legrand. So to get into it, before we get into the meat of the discussion, I want to do a bit of a kind of recap and a refresh as to what's happening in the market. What are the major trends when it comes to AI and power? We've got to understand what exactly we mean by AI. So what kind of models are we seeing, and what is the kind of demand picture shaping up like? Bill, perhaps you could speak to that.
Oh, holy cow! What a great start to this conversation, Alex. And I'm really glad to join you here for this DCD Power Hour. I did not just totally change the name of this webinar. Um, it's great to be here with John and Calvin. We're gonna have a really fun chat. Hey everybody! So before I answer this, I just want to make sure that we're clear. We're not talking about AI from like 20 years ago. That's been around with us for forever. That my wonderful Amazon device that you can't see can do, and my phone. We're talking about a technology that, please follow me for a second here. For the first time ever in humanity's history, we can ask data a question and get a conscious answer back. For the first time, we have a system that can think. Now, I'm not talking like Skynet level, but can think and give us original content, whether it's video, text, audio, pictures, whatever the case is. You just ask it. Now that has repercussions. So let me kind of answer this question with some things to think about as we dive into this conversation. Everyone here is a user of generative AI. Every single one of you listening. If you used Google or Bing recently, it doesn't have to be ChatGPT. The first response you get now is no longer a blue link. It's a generative AI response. But what does that mean in the context of power? So a single Google search can power a 100-watt light bulb for 11 seconds. All right. A single GPT-like query. Now, I say GPT-like because my organization at Apollo, we don't work with ChatGPT. We create similar like services. Is 600 to 800 times more powerful than a single Google search. Now, the reality of the situation is we don't run them in single batches. We run them in queries, about 6 to 8 queries per process, 6 to 8 queries per process, which means that really per single interaction with a GPT-like instance, you're talking like 1 to 2 kilowatts. Basically, in some senses, it's enough to charge this phone like 60 times. It's an extraordinary amount of power that we're consuming. And it's a massive paradigm shift just because the way we're interacting with data has changed. So the question is not even so much what kind of models are out there, because what we can do now with data, our imagination becomes limitless. It's really what we can create with this information, with this data, what questions we can ask. So we're experiencing this fundamental shift in humanity, and right alongside with it, we are asking us, John and Calvin, this entire industry, cool, everyone. You've been operating at 10 kW rack. Good job. It's time to do 60. 50, 60, or even more per rack. And that's the biggest change that we're experiencing. It's not just about the models, it's about the infrastructure there that needs to support it. I'm going to stop right there. It's just important to understand how much of a difference it is between a Google search and asking, your favorite Dolly or ChatGPT engine to make you your favorite superhero as like a puppy or something. I don't know. But that takes up an extraordinary amount of power.
Mhm. Fabulous, thank you, Bill. And Calvin, it's not all a chat GPT story, but it's a fairly good indicator of how demand's shaping up and what might be coming down the pipe.
Yeah, and I think that's fair. Everybody's familiar with Chat GPT, and they love to talk about it, and I think we've all played with it. I know I did a query at one point on power quality, and actually was very impressed with the information that came back. I started to worry if I needed to maybe be looking for a new job, but it actually the growth in Chat GPT has been phenomenal, but we see the other sides of this with our customers and training the models that Bill's talking about. And it's not Chat GPT, it's hundreds of organizations making unbelievable investments, which we'll talk about it here shortly in their infrastructure, in the hardware that it takes to train these models. And that's reflecting back in demand for products in data center space. It ripples really through our whole industry. So it's not that it's in the future, or it's not that it's here now, and the growth it's really driving is phenomenal. So this just kind of sets the stage a little bit. I think it gives kind of a who's who right now. This chart probably changes weekly with all the different organizations. We're familiar with a lot of people that are immediately purchasing and buying the GPUs because they need power, they need space, they need everything right now. They need cabins to put it in. So we see that reflecting back. But if you look, and it kind of gets corny, it kind of gets to like changing our lives. And admittedly, right now it'll be personal assistance and it'll be writing, but before you know it, it's really going to touch everything. And that's what we're seeing in the industry is that the investment is real, the demand is there, and this is happening now. It's not, we're not talking about the future. It's going on right now.
Brilliant, thank you. So how is the capacity build out going to support, this AI demand and the sort of exponential growth we're seeing?
Well, I think Bill nailed it on the head a little bit. One, so if you look at this slide, this talks about the investment, right? These are in thousands of units, and we all know that each one of those GPUs is about 40 grand. So the investment is the billions for some of these companies, which is phenomenal, and that's just on this part of the infrastructure. Um, Once you make that investment and you're looking at training a model, for example, you want to do that as fast as you can because you've got a lot of money, a lot at stake. You throw as much horsepower at it. When you look at it from our side, it's power density, right? And it's not the old days where, oh, I bought this blade server or whatever, and it uses a lot of power. And I'm going to kind of dot these things around the data center and create some hotspots, but I'll manage them. You're talking cabinets that easily are 400 volt, 60 amp, multiple drops of that. So 30, 40, 50, 60, 80 kW is just it's in these applications it's really becoming standard.
Brilliant, thank you. So to move the conversation on a little bit, I want to talk specifically about, what power is looking like in this era of AI and understand, in particular, whilst we see this huge amount of growth, what in particular are the problems and what the pain points are. We've got the kind of high level problems and then in the facility all the way into the cabinet, looking at the rack level. But, John, perhaps you could, help us contextualize all of this and how data center power capacity, kind of aligns with sort of these broader trends.
Yeah, sure, Alex. I'd be glad to take a stab at that. So, what's interesting to me is that, having been in the data center rack and cabinet business now for going on 30 years, when something is as ubiquitous as the data center rack, it tends to become invisible to those that use it, right? And so, if you look at just about every slide that we've shared so far this morning, and when you listen to conversations, as Bill kicked us off today, about what's happening with density in the data center, the unit of measure invariably is per rack. Mm-hmm. And we have seen industry averages. It seems like it skyrocketed from 6 to 8 kW to, as Calvin said, 60 to 80. And we have several projects we're working on where customers are deploying in excess of 100 kW per rack in production. For me, it's kind of like the story, if anybody's familiar with the bamboo tree, right? It's used as an analogy pretty commonly, that when you plant the bamboo tree, you put the seed in the ground and water it and care for it. And for the first 3 to 4 years, nothing happens. And once it breaks the surface, it grows 2 to 3 feet per day. I think that's what we're seeing in the data center, right? We've been talking about density is coming, high density is coming, and arguing back and forth in a friendly and professional way most of the time about what high density actually meant. Well, it's here. And from a rack perspective, what got us to where we are today not only will not take us to where we're going, it's not sustaining where we are today. And what I mean by that is, if you think about, just take a step back and logically analyze what's happening at the rack, to drive the densities that we're driving, not only is more IT equipment going into the rack, which, by the way, creates mounting challenges because that equipment tends to be larger. It tends to be heavier. So now we need a rack that will actually support the weight that we're putting in the rack, which is growing exponentially. We're dropping power in many cases. Data centers, instead of having raised floors, are going to slab, which means power is coming in from overhead bus. How do we accommodate that power coming into the cabinet? The equipment that gets deployed, the cable management challenge because of the myriad fiber and copper cables that need to be managed, that introduces a new challenge. And then last but not least, cooling. So the cabinet has to not only provide for unimpeded airflow, but also now we're seeing the implementation of in-row cooling. How will the cabinet and the containment deal with in-row cooling? And then for rear door heat exchangers, now we're talking about putting a physical load on the back of the cabinet that creates additional stress. And then I know I said last but not least, but I skipped over a point. Most of the cabinets that we ship, I'm going to say directionally 75% of the racks and cabinets that we ship do not go directly to the end user data center. They go to a third party integrator where that rack, which costs a few $1,000s, is populated with millions of dollars in some cases, or at least hundreds of thousands of dollars. The rack and stack integrator is populating, cabling that cabinet, and testing it. Now it needs to be crated up and shipped from point A to point B without damage, hopefully, right? So just about every aspect where everything comes together in the data center is at the rack and the cabinet. And we're at a point, finally, I've been waiting for this for 30 years, right, for the cabinet to no longer be considered as an afterthought or a commodity. The cabinet now, to support AI, needs to be a very, very well thought out, designed and engineered, fit for perfect purpose part of the system solution.
I have to add to that because I was taking some notes and everything that was being said, and I think it's brilliant. I'm actually going to validate pretty much everything you said with real metrics. So, the 2024 AFCOM State of the Data Center report was just released recently, and we asked the question around power density. And I think what's really important to understand is these densities, how much has changed in the last year. Now follow me on this for just a second. We've been asking the average power rack density of the industry in this report for the past 8 years. Now, about 8 years ago, the first time that we asked this question, that rack density was about 6.1 kW per rack. Now, the good news is that we asked that question again this year, and it is more than doubled. So, like 12 kilowatts per rack. But that's that's nowhere near enough to actually support some of these new and advanced kinds of AI systems, right? When you take a look at an entire rack, one DGX unit is 10 to 12 kW a rack. So what are you going to do? Just put one in there and a whole bunch of blinking panels? That's not going to be very effective. Um, and so in that sense, I see that in the report, 60% are actively looking or trying to work to increase their rack density. 58% are doing it by improving airflow, 42% by doing it with containment, and another 40% are doing it with liquid cooling like rear door heat exchangers. So we're seeing this industry realize rapidly just how quickly things are evolving, and we're going from 10, 15, remember when like 20 kW a rack was like, wow, that's pretty dense, and now we're pushing it to 60, 70. Here's the reality that I just want to make sure everybody's clear. Creating a hybrid architecture between things like rear door heat exchangers and good containment and airflow, that's one of my favorite methodologies. You don't need to put things like immersion cooling in there. With a good rear door heat exchanger architecture, you can put in like 100, 120, 135 kW per rack. And here is the most important part that I want everyone to sort of think about. Break away from the 42 unit paradigm. Use that vertical space. That's something that we've been seeing quite a bit in the industry, especially when it comes to putting in more of these DGXs. And let me give you a very, very specific example, then we can move on. One of my partners at Apollo, a data center company, actually, they put in taller 60 kW rear door heat exchanger rack. Now, this is a traditional data center that went on this journey with us and went ahead and put in these racks, and they're able to put in six 6 DGX H100 nodes. Each one of them was about a 200 between 200 $250,000. So you need to not be spending $500 on a rack. It's really important to make sure you invest in that infrastructure because what's going in there is really, really important. But they went on that density journey and they were able to accomplish that by creating a rack that's generating millions of dollars in revenue for them. But it's impossible to do that until you rethink your architecture just a little bit. And what you said was perfect. It's a big reason why, traditional raised floor data center architectures, you're going to have to make sure those tiles can support the weight of those AI systems because the last thing you ever want is a leaning tower of a rack. That's a horrible situation. No one wants to see that in a data center. So everything that's been mentioned so far is so imperative to understand, but it's just this paradigm shift going from 10 to 15 kW a rack to 50 to 60. It's not scary. And getting there, at least from what I've seen and taken some data centers in that journey, is not like climbing Mount Everest. It just takes a little bit of imagination and our architectural restructure, just a little bit.
Bill, if I can just tag on to that, I totally agree with you. And I'll tell you that very few of the racks that we manufacture and ship anymore are 42U. The de facto standard has become 48, and it's very common for us to ship 51, 52. Really,
Yep.
the limiting factor that we see anymore is actually the access and egress to the building itself, right? If you can safely fit it in there, let's use that vertical height. But when you said raised floor, most greenfield data centers today are going to slab floor. So here's another thing. Not only should we look beyond the 42U in height cabinet, the 24-inch wide or 600 millimeter wide, the reason that racks are that width was so that they would align with the floor tile, a 2-foot by 2-foot floor tile, or 600 by 600 for those of us who have adopted the metric system. I heard it's coming to America soon, but not quite here yet. So get ready for that. That's going to be that. We're going to do a webinar about that. The metric system is here. Americans don't know what to do. But please start to think beyond the confinement of a 24-inch wide rack. We're doing more and more when we get to work with the customer and design a built-to-purpose rack. We really start at 30, 31 and a half, and we have a customer that just recently went to 36 inches wide because all bets are off now, right? It's a green field, so let's not constrain ourselves based upon things that used to be factual years ago.
Well said. I agree with you, and I'm gonna make this statement. One of my mentors in this industry, Peter Gross, actually taught me this statement. The data center industry loves innovation as long as it's 10 years old, but we don't have 10 years. We barely have 10 months. So in a space where you think, for example, 42 units is like the de facto standard or the measurement architecture is all you can work with, you'd be surprised what you can do in your facility by just some slight re-architecture or creating, a little space where you can create these high density workloads. Um, every data center is going to become an AI data center. It all depends on how quickly you can get there and support these kinds of systems. And by the way, you're absolutely right. I believe I saw a statistic recently from a manufacturer that said like 85 to 90% of all facilities they being able to deploy right now are all just slab based flooring, which I think it's fine. I mean, that's probably the best way to go.
Yeah, here's the thing, though, that when you said about the floor supporting the weight, agree with you emphatically, but don't, please, if you're designing a new data center or going into a data center, don't automatically assume that because you've got a slab floor that there's not going to be weight problems there. We had a challenge with a customer in a data center that will remain nameless, where the racks rolled in. They were on average, they weighed more than 3,000 pounds per rack. And when they rolled into the data center, they actually started to, the casters actually dug trenches into the floor under that weight. So even with slab, you still need to perform due diligence and realize that 3,000 plus pounds is going to be rolling onto this floor. How are we going to handle that? Even if it is a slab, can still be a problem.
I'm writing that down. Thank you.
Mhm. On such considerations, we got a provision for, obviously the weight, the size of things, but when it comes to the tech stack, Calvin, we also have to be able to maintain and service it, presumably, to keep everything ticking over.
Yeah, and it really goes back to really both the points that John and Bill have made. To reach these densities, a lot of our customers are actually installing. I mean, you always typically have an A and a B in feed right in a data center cabinet, but they're having to double that in some cases on the power side to meet these densities. So in some cases, instead of two PDUs, you may have three, you may have four, and that packs a lot of stuff in that box that John's talking about. So it does make for some challenges in maintenance and serviceability, but it's really what's needed today, depending on how your infrastructure is set up and how your drops are from your RPP or from your busway to get to that KW. So it can compound some of those maintenance and servability issues because you're putting so much into the rack.
No doubt.
Mm-hmm. And we've spoken a lot about the rack level over the last 5-10 minutes. Before we move on, Calvin, perhaps you could help contextualize this at top level. What is data center power capacity, currently looking like, and how is AI likely to impact, the kind of balance?
Well, I mean, obviously, we know the densities are going up incredibly. We are working on a lot of products, obviously, to meet those densities. Kind of the de facto standard for most people now in North America, kind of due to efficiency and due to KW, is kind of a 400 volt, 60 amp, 400 volt, 63 amp in Europe is what we're seeing the most of. But we've been pushed before by Bitcoin miners and other people, 100, 125 in Europe amps and even higher. And so we are seeing more of that. And frankly, we have those solutions. We always have, but now there's just a lot more demand. So it's the struggle of keeping up with that demand and servicing those customers. And we understand it's real just by looking at the people we talk to and what they're asking us to provide in the quantities they're asking us to provide. And like Bill said, when they want it, which is pretty much yesterday. So
I want to make sure that we stress on that point that Calvin just made, the quantities in how much they want, right? And so this chart that we have in front of us is perfect. And everybody, please follow me along on this. I remember I attended a DCAC live event in Austin. I had my cowboy hat on and everything. And I was sitting in the front row, and up goes this really cool, JLL goes up there, real estate company, and they're starting talking about transaction sizes, single deal transaction sizes. And I grew up in this industry. I'm a millennial, been here for 20 years. I'm really lucky that I had a chance to get a network engineering degree. And I used to, I worked in network closets and data rooms before they were even called data centers. And I've seen pizza box servers, and I've seen rack that's like a couple of kilowatts. And we've seen this evolution of the data center back in the day when I was like, a 20, 30, 40, 50 megawatt deployment is massive. That's a big, big facility. Here I am sitting there. This dude puts up this PowerPoint presentation and says, we are now getting single transaction sizes of 300 megawatts. Single transaction sizes of 300 megawatts. Now, just to kind of think about that, the African continent consumes between 300 and 400 megawatts. All of it in the data center industry. India, the most populous country in the world, is like 400 megawatts. So here in America, we're getting single transaction size of 300 megawatts a pop. Now, anecdotally, that person came up to me after. He's like, I didn't put this up on the board, but we're starting to get questions about 500, upwards of a gigawatt of power availability. Now, if you think that's silly, take a look at the slide that's up right now, data center power capacity. In one of the recent quarters, NVIDIA shipped something like 900 tons of their H100 cards. We're not even counting the numbers anymore. It's like by weight. And if you were to hypothetically put all of those cards in action at one time, that's 30 gigawatts of power. Where do we have that? I mean, that is a ridiculous amount of power consumption, and that's not slowing down. So to the extent of, again, what John and Calvin are talking about here, the amount and the size and scale of this is a new era of compute that requires a new era of architecture for the data center. And again, it's just none of this is going away, especially that IT load capacity for AI.
Mm-hmm. Fantastic, thank you. So I just want to move the conversation on a little bit. I think we've touched upon, a few of the kind of core pain points and problems, but it's always good to further contextualize in terms of what's happening within the wider data center ecosystem. I think, at a top level, Calvin, and just to come back to you again, what perhaps would you say is wrong with current infrastructure? What are your customers saying to you, and what are they struggling with?
Well, besides a lot of the challenges we've mentioned now, there's a lot of different problems that we've really tried to solve with some of our newer products in particular. And, every once in a while we'll get a large data center, and like John says, they'll go nameless, where they're maybe having some power issues, and they'll say, well, there's something wrong with your PDU, and we'll put a bunch of engineers in a car with, a few $1 million worth of test equipment. Will go out and look, and even some of the bigger, newer facilities have some power quality issues. So what we've tried to do overall is look at how we can minimize those problems. So if you look at all the devices in the data center, they all have switch mode power supplies, and they all create harmonics. And if you're having a problem and you're seeing uh, power supply service failures, you're seeing odd power factors, reduced efficiency, noise, communication issues, a lot of that can be related directly back and to the power quality. And that's really where our device sits, is kind of the last piece of that critical physical infrastructure power chain, sitting at the devices. So we've done a few different things. One, we have looked at power quality, and we've got some metrics like crest factor, total amount distortion power factor. You can look at those and in real time track those and understand what's going on if you're having problems. If you do have particular issues, we can do a waveform capture of the current and voltage in certain situations, or manually if you want to see that. And then usability. So there's certain instances where you may have a problem. Let's say that a power supply fails, it blows the branch circuit breaker. All of a sudden, you need smart hands. It gets critical if it's a remote facility. You're gonna have to get somebody in the cabinet, unplug everything from the branch, reset the breaker, plug it back in, figure out the outlet, therefore figure out the device. We've got tools now where we can just tell you which outlet or which device. And when you have that failure, we'll show you a waveform capture of what actually happened. So, and we've got multiple cases like that for usability. So we're really trying to add a lot of intelligence back into the intelligent PDUs based on use cases that our customers have given us as far as what their pain points are. And I think it provides a ton of value for the end users, basically.
Awesome. And John, you mentioned earlier on the cooling component. We can't look at power in island mode. Absolutely not when it comes to these high densities. So, when it comes to bringing those cooling solutions, whether air or liquid, into the fore, how are you utilizing those to manage these power densities we're seeing?
So we're seeing two trends that are popping up everywhere, literally. Number one is containment, and number two is close coupled cooling. So containment, in order to be able to deal with these densities, we need to isolate them. And containment, an analogy I like to use would be, people go, well, can we cool it with air? Can we cool it with space? Yes, you can, but we also need to look at operating cost, efficiency, and environmental impact, right? So cooling, here's an example. If we were to go grocery shopping, I brought home all the groceries and took everything and put it out on the kitchen counter, I could keep that food cool by bringing the temperature of my house down to 48 degrees. Or I could do something crazy like put the stuff in the refrigerator. Right. So it's not dissimilar from the data center, right? So we need isolation. That would be the refrigerator, if you would. So we've got it contained. And then close coupled cooling. The closer we bring the cooling source and heat dissipation to the heat load, the more efficient in most cases we're going to be. So aisle containment, absolutely positively. And then at the rack level, while we are seeing, we're having to adapt some of our cabinets for cooling manifolds for liquid to the chip, what we're seeing really, I hesitate to use the word exploding, but growing very quickly is in-row cooling and rear door heat exchangers. So, and we've seen, I think Bill spoke about it before, rear door heat exchanger solutions, passive rear door heat exchangers that can handle 40, 50, 60, 80 kW, and then active solutions actually up to 200 kW per rack. And those are products that are available as we speak today. So that's really what we're seeing, that the implementation of containment everywhere, and then in-row cooling, rear door heat exchangers for a closer coupled cooling solution.
I want to add to that just a little bit, John. I think everything you're talking about is brilliant. So at Apollo, we are a software and infrastructure layer, right? So we're like the software layer that allows any data center to basically become an AI shop to allow to offer these services to their tenants. The challenge is their infrastructure is usually not anywhere near ready to support this stuff. So the question becomes, Bill, how do I catch up? And they're just not sure. It's a traditional type of data center. And remarkably, John, everything you said is perfect. You don't have to rip out your environment to create higher levels of density. Some of the things that we've been really successful is doing, either a computational fluid dynamic study or having sensors. Please have sensors in your rack, a couple where you need them at the ingress and the egress of where the heat comes in and where it goes out. Because the more you know about your environment and you lose those hot spots and cold spots, and the more efficient that it can flow, the more density you're going to get. Now, number one, you have to have visibility into that, right? So don't just guess where you're inefficient. Make good, intelligent decisions, because then you can make your buying decisions based on where you actually have those gaps. That's number one. Number two, John said absolutely perfectly. Air containment is one of the best ways you can start to figure this out. Once you know where you have inefficiencies, cool. Where can I put in maybe a toolless design or a better rack architecture or some kind of an airflow mechanism? All right, now I got this part down. Now how do I increase the density of the rack? Now you have to maybe do like directed airflow, something improvement of how you actually help the rack breathe, quite literally. Now, you can only physics, you can only get to a certain amount of density with airflow. At Switch data centers, where I was for about 4 years, they were able to get like 50, 55 kW per rack with just airflow, but that was really difficult to do. You can have noisy neighbors. You have to monitor your delta T, the pressurization, but they had a really cool chimney architecture where you're going to hit limits. So how do you get beyond that 40, 50 kW rack? That's where you start to take a look at those rear door heat exchangers. And again, these are the recommendations that we're giving to our data center partners that want to evolve, right? Figure out where your problem spots are. Go for the low-hanging fruit as far as containment is concerned. Understand how you can improve airflow in and through the rack and entire environment. And finally, rear door heat exchangers are wonderful. Even with traditional ceiling heights, you can still put that water in there, dissipate the heat from the rear of the rack using liquids, and you can really push that kind of architecture forward. Everything John said right now does not require you to go in there with a forklift and rip stuff out. It just requires a little bit of re-engineering and rethinking. And to be perfectly blunt with you, we've taken data centers from 5, 10, 15 kW rack into that 60, 70 by literally everything John just said and applying some of these methodologies to your thinking. So getting to this high density AI state is not impossible. It's not an impossible mountain to climb. It just requires you to put in a little bit extra gear sometimes or rethink how you're architecting your environment.
Brilliant. And we've seen a lot of leaps and jumps, especially given the kind of Gen AI quote unquote boom, and all the kind of knock-on impacts and proliferation of HPC since then. But it's always nice to kind of draw a bit of contrast. Looking at a moment in time. Now versus this time last year. How much has things changed, and that kind of delta. How do you think that will stack up between this year and the next year to come? Perhaps to Bill.
So how is the density going to be changing, or for the application specifically?
Yeah.
So, the reality of the situation is that, the use cases are driving the scenario that we have right now in our industry. We see just how quickly these applications are starting to change. There was, ChatGPT recently released their movie engine, right, where you can literally start to create movie-based content, and all of this is going to create a new level of density. Folks, we're moving beyond the conversation of SQL servers and Exchange boxes and VMware and Citrix to AI engines. And the reality of the situation is that my organization, Apollo, is not being driven by our data center partners. It's being driven by their customers. So data center customers are saying, well, maybe sometimes I don't want to be in Amazon, or I don't want to be in one of the big cloud providers. I have all of my critical infrastructure with you already, my databases, my email servers, my virtualization boxes. Can you also handle my AI workloads? Because I am paying an arm and a leg in Amazon or wherever else where they're doing a good job. I just don't want everything in there. And the resounding response, usually from a traditional colocation, is no, I can't do it. I don't have the density capacity. I just can't do this. And so this requires, the customer. You have a driven customer market that wants to be working with you, but doesn't have a data center that's quite ready yet. So the reality of the situation is the applications, the use cases that are driving enterprises today are going to be the reason that we're going to see proliferation for new power designs and infrastructure designs in our ecosystems. So it all becomes a question of how quickly do you want to be able to support your customers, because otherwise it's just an experience of revenue bleed into some of the big cloud services. So the application, the use case right now, especially, it's the main reason why we're seeing this entire discussion, this change, is massively rapid change in how we design infrastructure today. And please understand, this isn't going away. This isn't a fad. This is as much of a fad as when we stopped riding horses and started driving the Model T Ford. This is as much of a fad as when we stopped riding trains and started flying in airplanes. What we're experiencing right now isn't a shift in technology. It's a shift in
Mhm.
humanity, how we interact with data as people, right? Whether we're consciously thinking that we're using generative AI or not. We've been conditioned to interact with data so well over the past 20 years. Here's a question, here's a blue link. Here's a question, here's a blue link. That's gone. That's it. That you have generative content creation now everywhere. That's the application that's driving all of this.
So will that kind of, beckon a need to move away from traditional design? Obviously we're things are, we see incrementalism, but this is a kind of big shift in the market. John, what are your thoughts?
Well, I think that I agree with what Bill just said. We're seeing, not evolution, we're seeing disruption. And we don't know what we don't know yet. A quick story. I guess it's about 15 years ago now. I was at an Apple data center in California, and the gentleman I was there meeting with brought me to a site, and the focus was racks for high density application. And I always like to ask about, just out of curiosity, what the application is. And this gentleman, whose name was, if anybody remembers, Buzz Sorrell from back in the day, Buzz looked at me and said, "John, we're going to do away with this whole Walkman CD thing. We're going to have a device where you can download music from the internet and listen to it on this device. And that application is going to drive cabinet densities that can be 4 to 6 kW per rack." And I remember walking out of the meeting, getting in my car and going, these guys are stoned. That's who's going to download music from the internet. That's ridiculous. And 6 kW per rack. I'll sell him a cabinet, but boy, he's really, this guy's. And overnight that became, we adapt so quickly that things that we're talking about on this call right now, there will be, I don't know, 2 years, 3 years, maybe 5 years from now, someone will be on a webinar with probably, I'll be out of the industry by then, God willing, but somebody will be going, "Hey, I came across an old recording, and there were these guys, Calvin, Bill, and John, and they were freaking out over 60 kW per rack. What a joke that is," right? Because we're going to see gigawatt data centers, and we're going to see, loads. At some point, the whole paradigm has to change, and we'll move on from what we're doing now to something different. And I believe it's going to happen very, very quickly. But the best that we can do right now, I believe, is to keep an open mind and move away from doing things just because that's the way that we used to do them, right? Easter is coming up, and I fight with my wife every year about, we're going to buy a big ham, and she cuts the ham in half and puts half away and cooks half of it. And the reason that she does it, I actually found out, is that's the way she was raised, because her mother had a very small oven. Right? So we're doing things because that's the way that we used to do them, and it just doesn't meet the technology that we have today isn't even being used to its full efficiency, I don't believe. I think we can wring more out of it. Like Bill said, we don't need to do forklift upgrades. We need to take a look at technology that's available right now and apply it in a more, I won't say more intelligent, but a more open-minded approach, knowing that, as I said earlier, what we did to get us here is certainly not going to take us where we're going.
Nope.
Mm-hmm. I think you make an excellent point there, John. It's all too easy to follow kind of legacy protocol, SOPs, architecture. But you've got to be the disruption you want to see in the market, and kind of change the face of that. Calvin, we've got about 10 or so minutes left. And you spoke about 10 minutes ago, you touched upon your waveform technologies, which you're looking at in terms of kind of the visibility and what's happening when it comes to power and identifying where those problems are. I'd be keen to dig a little bit deeper into that for a minute or two, if that's okay.
Yeah, and it's tough. It kind of goes back to the sensor conversation that we just had earlier. There was an old mantra. I think it was coined maybe by the Green Grid a while ago when I would go to those meetings that Dean and those guys would run, and it was you can't improve what you're not monitoring, right? So whether it is understanding the amount of power you're using or you're not using, stranded capacity, whether it's looking at temperature and humidity and other things, whether you're following ASHRAE or not, understanding so you can look at containment like these guys mentioned, or whether it's the next level in making yourself more efficient with some of the tools I talked about with the branch circuit monitoring, or understanding power quality problems, or understanding why you're having a higher failure rate, say on your server power supplies, whatever it is. All those things go back to the monitoring. And I think to John's point, we can do a better job. I think a lot of these companies have the tools in place. Some use them, some don't. But to have success, I think in some of these new applications, you are going to have to look closer at a lot of these things. You are going to have to look. You may have a smaller window if you have a problem, so you better look at your temperature closer. You better understand your power usage so you don't look at, understand stranded capacity, understand what you have available, those types of things. And so all this just really ties into you can't manage what you don't understand and what you don't monitor. And so the monitoring has really just gone kind of to the nth degree, because our people are busy. You're in the data center, you think you have a problem. What does it take? Okay, do I need a power quality monitor? Where do I get it? How am I going to track the data? Am I going to stick it in one cabinet and then I'm going to try to monitor that data and tie it back to my VMS or a DSIM or whatever and try to get the data? Or am I just going to put in a tool like this and I'm going to know over time what my power factors have been, what my total harmonic distortion is, and then I can go back and I can look, and historically I've already got all that data. So when you're trying to troubleshoot and solve problems and see where you have problems, it's very, very easy to do. It's not superhuman effort to try to diagnose and solve these problems. The data is there at the tip of your fingers. And that's what our customers have been asking us for. And that's what we try to deliver at a 0.5% accuracy, which also is unique. Industry's about 1% now. And then add the usability stuff that I talked about. And on that branch circuit example, we can even bring the branch up remotely and keep the troubled outlet or the troubled server, just keep that outlet off. So you don't even have to go to the site to bring that up if you don't want to. So it's those types of things that I think are going to help us get to these higher densities. They're going to help us manage AI. They're going to make our lives manageable. We won't be pulling our hair out as much because these are tools that, if used and used properly, just really kind of save the day and make all of our lives easier. So it's what our customers have been asking for. It's been difficult to deliver through maybe a pandemic and some chip shortages and a few other things that have happened in the world. But it just makes a lot of sense once you dig down into how these things can be used.
Brilliant. we've done a bit of a whistle stop tour of all things power, all things AI, what's happening at the rack level, the grid level, and the kind of all the architecture requirements in between. I want to ask, is there anything else to the AI and power story we haven't touched upon? Obviously, regulations shaping up. Over in the States, you guys have got your own laws on a state level rather than federal. I mean, it's like a kind of patchwork blanket of regulation coming up. I mean, what's happening there, Bill?
I mean, let's not sugarcoat it. The big news right now in the industry and what we saw is, Europe basically passing the world's first act to regulate AI. Something that was taken up by European lawmakers, and I'm not going to say that regulation and making sure that we monitor and manage how we work with AI systems, that's really really important. One of the things that I think we're going to be seeing certainly here in the United States and across the world is secondary and tertiary markets are going to begin to emerge far more than ever before to support AI systems. We're going to see more impact from the local communities, right? We're going to have to make sure that we have a good presence there, um, that we have good conversations with local communities to make sure that what we're building and creating is serves them well. But with anything else, it's going to be sometimes a bit of a challenge to work with people from utilities commissions sometimes that have a more archaic legacy perspective on how data center and power structure should be done. But I think the good news is that, and again, we're going to be talking about this at the AFCOM Data Center World event, is that we're going to be seeing new power sources, things like nuclear, right? A great way to supplement intermittent, solar or wind energy that just sometimes is inconsistent. So I think what's really exciting about this, and certainly right now, is how laws and regulations at both sort of the state and federal level are going to be shaping and shifting to support this kind of market. But I mean, if you take a look at the global landscape right now, the kinds of power densities that we're starting to ask for are extraordinary. So places with limited power, like the UK, where you're an island basically, or even places like Europe where they're not capable of supporting anything over like 150 megawatts unless they're firing up coal power plants. That's going to require a little bit of rethinking, and that's just the way of this industry and the way of technology. We evolve. We're never complacent, and the infrastructure that supports these new use cases must evolve alongside with us. So you're going to see changes. I mean, there's not no way to sugarcoat it. There's going to be changes at the state, federal, certainly the global level, definitely around AI regulation. And making sure that we can govern that, but also around power consumption. I mean, what's really fascinating about this, Alex and everybody, I think there's a loosely thrown about statistics that the data center industry consumes like a 1 to 3% of the global power, output. What's that going to look like in a couple of years if we start going from 10 kW a rack to 60? Does that mean we're going to be it's 6 times more power? So does that mean like in just a few years we're going to be like a quarter of the world's energy consumption? It's extraordinary. But what's crazy about that is it's possible. Like we might end up being at a place where, because of AI, because of generative solutions, because of the way we interact with data and the intensity and the resource utilization from that, we become a 20-25% user of global power, availability. That's extraordinary. I don't know if that's a prediction that all of a sudden DCD is going to be posting out tomorrow on LinkedIn. Bill predicts 25% utilization data center. That's fine. That's going to get some reads for sure. But I also don't know. Maybe.
Hmm. I think it also speaks to power at a big picture in terms of the power ecosystem becoming more of a kind of business, and I suppose we'll have to start thinking about new players entering that market. Whilst you say, Bill, even if we get to a point where the digital infra, the data center space is consuming a quarter of the world's energy, there's still going to be a huge amount of competition for that market share. Calvin, perhaps you could talk to maybe some of the other big players we're seeing in the market. You mentioned on an earlier call when we spoke Tesla as an example, and whilst it's not quite a Musk versus grid situation just yet, they're gaining momentum, right?
Yeah, it like Bill says, it ripples all the way through the industry. And to your European comment, Bill, as I understand it, there is a law now that all the data centers in Europe have to report their power usage, which is fascinating to think that they're monitoring it. I also noticed the other day that our Department of Energy was going to do a study on the amount of power being drawn by Bitcoin miners, and they canceled it. So I don't know if they can figure out how to do it, or even there's some places that are doing it in Nevada in warehouses you would never even suspect. But the demand is real. How we're going to deal with it is difficult. It gets also into to everybody with the promises of net neutral on carbon and the timeframes. How does that really affect things? A lot of the really big guys are in a particular industry, but they're also in the power industry, and they understand that. And there's wind, there's solar. A lot of places are putting in solar to try to supplement. I'm a little afraid that some of those efforts, if we look at what's upcoming, just aren't going to quite get us there. So it's not only a shift in the data center, whether it's cabinets or containment or cooling or power, but I think it's a fundamental shift in the direction of really some of the largest companies in the world. They've identified themselves as an AI company or a data company, or not necessarily a car company, as part of that vision. But even now, I think that vision starts to shift with some of the new things we're seeing. So frankly, it'll be fascinating to see how it kind of all turns out, frankly.
Yeah, fantastic. And you're right, in terms of reporting in Europe, I believe it's over 500 kilowatts we have to be reporting on. But, when we're seeing these densities at a rack level, already kind of in the hundreds, we're going to be having to report per rack if we're going to get to that density. It's an incredible landscape that's emerging. John, we've got a couple of minutes left, so I'm going to give you the final word. We've spoken a lot about technology, regulation, and the way the landscape's going to be shaping up. But we haven't spoke about, new approaches in terms of partnerships, right? We're not island mode anymore, and we're, operations are making, tangible strides to make sure that is not the case. Perhaps you could speak to that a little bit.
Sure, it's a very, like Calvin said, fascinating and also exciting time to be in our industry. New approaches and partnerships. What I'm seeing is really two levels. Number one, and most enjoyable for me, is the partnership with our customers. As again, the racking cabinet business, as I said earlier, really over the past decade or so had become commoditized. A customer would put all the focus on applications and equipment, and then almost as an afterthought say, oh yeah, we're going to need some racks to put that stuff in. We use 42U, 24 wide, go get us a good price and make sure they show up on time. Now, my team, and especially our engineering team, where we spend a lion's share of our time, is working with a customer, the largest customers in the industry, to engineer rack solutions that will accommodate the challenges that we've talked about in the past 50 some minutes. So it's no longer us as the vendor across the table negotiating with the customer. We've come around to the same side of the table to collaborate with the customer and focus on what the problem is. The challenge, it really is a challenge. It's not so much a problem. That would be too negative. But what's interesting to me and relatively new, in a very competitive marketplace, the need and the scale and the speed with which things are evolving has created an environment where companies that used to be our competition, the other large companies that are out there that we saw as the enemy, we need to win against them. Well, there's so much happening right now that no single vendor has the capacity to meet the need. I mean, cabinet demand, if I threw the numbers at you, it would just sound like I'm bragging of how many racks and cabinets we're shipping on a weekly basis. It's unprecedented. And that's only a fraction of what our customers are consuming. And what the customer and the marketplace and the need is driving us to do is to really, instead of just speaking about being agnostic, we really need to live that, in that the rack that we manufacture at Legrand must be, to be of value to the customer, must be interoperable with rear door heat exchangers from competitors, with containment from competitors. Now, of course, we put a lot of time, effort, and investment at Legrand into having an integrated white space solution. And I believe we have the best in the industry. But because of capacity and because of legacy, There really is a collaborative energy now where I find myself on calls on a weekly basis with engineers and salespeople and leadership from companies that traditionally have been our competitors in a collaborative effort to bring a solution, a holistic solution to the customer. So really, not that we hold hands and sing kumbaya, but we're moving in that direction, which I think is great for us. And more importantly, I know that it's great for the customer because they're just getting a better solution.
Absolutely. And I think, as you say, John, and testament to, having the three of you on the panel today, having these conversations with different people, different organisations, it's only going to lead to helping come up with innovative and original thinking to solve those problems.
Absolutely.
Brilliant. We are running down the clock, guys, so I will use this as an opportunity to thank you ever so much for taking the time to share your thoughts in unpacking the evolution of power and the AI landscape. I've thoroughly enjoyed the conversation, and we're going to have to book another one in because I've got several more questions I've got to run by you, so it's got to be a to be continued.
Thank you.
Love it. Thank you.
Thank you, Alex.
Excellent. So our audience, thank you so much for tuning in. If you do have any questions of your own, please reach out to Calvin, John and Bill. They would be delighted to hear from you. Thank you again to Legrand for sponsoring this episode. And if you did miss anything, this episode will be available on demand shortly. Please do remember that the Critical Power episodes come out on the channel each month, the latest in the space, and we look forward to seeing you then. Thank you.